Hello? So if anyone has a laptop, please go to the site so that at least somebody can do a live chat with me. And maybe whoever that person is can send out any questions from anybody in the class. I see that a couple of people are checking into Swarm, which is good. So at least people are there. Unfortunately, I don't have a webcam to see everybody's face, so I'll just keep talking. I haven't taken a NyQuil yet, so I should be good for at least another hour or so. NyQuil. Whoever invented that should get a Nobel Prize, Nobel Peace Prize, for that matter. Okay, I guess I'm gonna go ahead and get started. So if anybody wants to ask a question, please go on the live chat. I can't really hear anybody right now, but I'll go ahead and just go over Python Lab B. So let's kind of review what we did last time, where we started with a set of numbers and said 0.0, 11, 0.0, 5.0, 3.0, and 7.0. Okay, there's a list of floating point numbers. A couple of the functions that just to review, you can do the length of this. Oh, didn't want to do that. Okay. Numbers. And there is also a sum function built in. So if I say sum numbers, okay, we can get that information. But what we really want to do is we want to actually, well, we're not getting any, is nothing coming in? Hold on, let me check to make sure. Let me check to make sure. Okay, we should be, I appear to be going, so I'll stop this now. Anyway, I'll just keep going. Hopefully it's being recorded. If not, we will re-record this. So printing the numbers, the length. So just check something here. So if we wanted to count the number of elements, similar to the len function, what we would do is we would say c equals 0. And then we would say c, and then for I in I in numbers, c equals c plus 1. And then we can print c. So we can see that we're doing the same type of functions with that. Okay, I see that Brian, you guys just hopped in, so hopefully you're seeing something. If somebody can reply and say yes, that's the case, that'd be great. Let me just go back here. I'm just trying to monitor what other people are seeing, but that's not working right now. So we just did the, we want to do the sum, for instance. We would say s equals 0.0 for I in numbers, for I in numbers. We would have s equals s plus I. So we can then print s in this situation. So you see that we're doing the same thing. So if we wanted to make this into a particular program, we would open up a new window. And let's do a print. Let's do the sum function. So s equals 0.0. And then we would say for I in, let's put in the list first. Let's call this numbers. .0. And for I in numbers, do the same thing, s equals s plus I. And then print I. Again, just review, I can run this, run module, and again, it has to be saved. And we want to put this into some file. I'm going to call this sumdata.py. All right, and there we go. It runs no problem. If we wanted to verify that, we can run the sum function also. So far this has been fairly straightforward, I hope. If not, somebody can probably get on Slack and let me know, either in the general channel, if they have a question. Right, but let's go to the next more difficult case, and that is actually trying to find out the minimum and maximum of a set of numbers. So let's see what we have for numbers here. Let's create a new set of numbers. Numbers is equal to 2.0, 11.0, 5.0, 3.0, and 7.0. Okay. Now, we sort of have to do the same thing that we've been showing with trying to find the minimum of this string. Now, we have to initialize the answer first. So we have to make a guess as to what the minimum value might be. And this is something that a lot of people actually have questions, or not questions, but how do we initialize the first value of our guess? Okay, what we're going to do is we're going to do a for loop, okay, for I in numbers. And let's just do this just to show what's going on here. That somehow we want to, as we go through the entire list, we want to find the minimum. Now, most people will say, well, I can see what the minimum is. But imagine if this was a million elements. It's very difficult to actually go through those million elements and find out which one is the minimum. So we're just starting with this very simple example to show how you would do that, and the process of actually doing that. So what we really need to do is we want to start with a minimum, and we need to make a guess. Okay, what a lot of people incorrectly assume is that the first value that we want there should be something like 0 or minus infinity or something silly like that. And that's, those all seem like reasonable guesses. But if you really think about it, what you want the initial guess to be is just any element in the list. So in this case, let's make it the first number. Okay, so numbers of 0. I'm going to print min there. It's 2.0. So what we can now do is we can just say, well, let's go through each element for I in numbers. Okay. And we want to somehow ask ourselves, can I compare what my current guess is against the guess of against the current one, right? So what we want to do is sort of come and use the if this then that concept. So we want to say if min, or if I, okay, it's less than min, what do we want to do in this situation? Well, what we really want to do is to assign the new minimum that we found. So the way to think about this is that what you're going through is you're going through each element in the array, and what you want to do is you want to find the minimum. So basically what you're testing is that you're going through each element and saying, if something is smaller than my current guess of what the minimum is, I want to make that exchange. In other words, I want to set my current guess to the new one. So this is what this is doing right here. All right. And if we just let it go, what we hopefully will find is the minimum. So print min. Okay, and that was kind of a, we sort of knew that that's what it began with, but let's do the opposite now where we want to do the maximum. So in this case, we would say max equals numbers of 0. Let's look at that. We know that's the wrong answer because if we look at the numbers, we'll see that it's not the smallest number. So let's do the same thing. Go through each element in the numbers and then do an if statement. So what we're doing with this if statement, if the current number I'm looking at is greater than my guess on the maximum, in other words, if I is greater than max, then what this statement says is I want to make the maximum equal to the thing that I found to be larger than my current guess. Right? And we can see now that max does carry that other one. Again, we did this interactively. Let's now actually do trying to put it into an actual program. Right. And the way we would do that is sort of similar to what we see here. We would say numbers equals 2.0, 11, 5.0, 2.0, 7.0. And we can say, let's do the maximum here. Max equals numbers of 0. Okay. And then we do go through the for loop for I in numbers. If I is greater than max, max equals I, print I. All right, and let's run that. And let's call this max data.py. And hopefully the answer will be, ooh, okay, so I'm trying to think about what we did wrong here. Oh, I see. I see what we did wrong. If anybody sees what I did wrong is I said print I instead of print max. So you can make that change in this file and run it again. So, and it'll save it. We made a change, so we need to save it, and there you go. So that was sort of a common mistake where you typed the wrong variable to print out, which is what I did. It printed I and did exactly what I asked it to do, which is the last element, which is 7. So And we can do the same thing for minimum, but I'll leave that as an exercise for you to do. And let's see what we have here. What's next? I did skip one problem, which is sum squares. And I just want to go through that fairly briefly. Let's actually, instead of actually doing it interactively, let's actually create the file itself and just run it. So we'll create another one. And we have numbers equals. And you can cut and paste this stuff if you want to, but I like just typing things in just to make mistakes for one thing, so that I can show you what to do when you make a mistake. And we're going to use a variable called sum square, which is to hold all the squares of the numbers. And then we can say for I in numbers, and we can say sum square is equal to sum square plus I, and the you can either do I times I, or you can actually do I raised to the 2. Okay. And we would print the answer sum SQ here. So let's actually run that. Run the module, save it again. Let's call this sum SQ. Sum SQ data.py, and that's the answer. And hopefully that's right. I'm not going to go through and check it, but that's something you should check, something you can easily check in something like Excel. So one of the things I encourage people to do is when they actually write functions is to actually check them against what Excel may give. It's likely that Excel is giving you the right answer. So now, what we want to do is go over a different concept now, and that is basically reading input data from a file. So up until now, we've been typing the files straight into the program itself. And you can see that that's actually very not very useful, because what you have to do is you have to go in, and if I wanted to add a new number here, for instance, I would have to go into the program and change it and add it and then run it again. All right. What's easier and what's more likely you're going to be doing is that you will have a data file that contains the data, the information. So let's actually create one. Okay. Let's create a new window, and let's type in the different values. I will do this sort of as single column, but you can do this in different forms. So in comma separated values, in some situations you may want to express this as a JSON file or an XML file, but that's a little more complicated. What I like to do is I like to start with something very, very simple, so that it's easy enough to compare with your other program. So let's start with this particular file. Let's call it data.txt. So I'll just go ahead and do that. Save. And let's call it data.txt. Let's actually do this interactively. I'm going to close this for now, just to illustrate a couple of concepts. So how do we actually get this into Python? And how do we actually get the data? And the way you actually start telling Python to actually access a particular file is through the following command. You would say something like input file is equal to open statement. And what you have to give it is the name of the file. So we will call this data.txt. And we will elaborate on this because a common problem that people run into is that they won't be able to necessarily find the file. So you have to give it a file name. And the next thing that you want to do is you want to tell it, how are you opening this file? So there's several states of actually opening a file. One is to read it. One is to write to it. And the other one is to read and write to it. I almost tell people to avoid the read and write at the same time, but just do either reading or writing. So in this case, the file already exists. So what we're going to do is we're going to read it. Okay. So what did that just do? Well, what it did is to basically, the way I want to describe it is it looked for that file, opened it up, and what you got back is, again, think of it as an ID, a social security number, if you will, for that specific file. Because the way to think about files is that they may have the same name, but they may have different locations. So sometimes this is actually how we actually see what's in the file. So we can actually look at this variable. It's not really going to make that much sense, but all you really need to know is that it is a reference to the file that we just created. Okay, so as you can see, it says the file is data.txt, and it tells you, you can think of this as the social security number of the file. So what do we want to do now? Well, there's several actions that you can do for a file. One of those actions is to actually get data from it. And let's do this. Let's call this data string. We can say input file dot read. Okay. So what this is going to do is going to read that entire file into this variable data underscore string. All right. So if we look at that, okay, looks like we read it in. Looks like we're ready to work on it. But as with the name, as what the name says, we have to check what type it is. Data string. Okay. So that means that we really can't process it the way we've been processing the original set of numbers. So if we look at numbers here, we say type numbers, we see that that's a list. But then if we say type numbers of 0 for the first element, we know that they're floating points. Well, we see that the data string here is strings, so we can't really process it the way we want to. So there's a couple of things we need to do. The one thing we need to do is we need to convert that into individual words. So we can do that by saying, we'll call this data words is equal to data.string. And hold on, data underscore string split. All right. If we print this out, you see that we have now taken that string and converted it into strings, individual words, if you will. So we still can't do much with that, or not what we intend to do in terms of numeric computation, because if we do the following, if we say A equals data words of 0, B equals data words of 1, print A, print B. But now if we say print A plus B, it doesn't work. It will, however, work if we say print float A plus float B, in which case that's what we want to do. What we want to do is we want to convert the words into numbers. So let's actually do that. We can do that first of all by starting with a list of numbers. So it makes, let's call it number list equals, started with nothing, or with just a blank list. Then we can say for I in, what did I call it? I in data words. So, excuse me. It's let's print it out for now, so we can see that it's excuse me, doing that. But we really want to do is we want to put it into this empty list. So we can do that by now saying for I in data words, and then we will say number list equals number list, and we will say float of I. So what we're basically doing here is two things. We're converting each element, each of these strings, into a number, and then adding it to this list. All right. So now if we say print number list, we have numbers for each one of those. We can prove that by saying type number list of 0. All right. And we can do the same thing that we did before. So remember, this came from an input file, and we're going to now actually process it. Same thing we did before. So let's say s equals 0.0 for I in number list, not number, something we just created. S equals s plus I, print s. All right. So let's actually do this example using, instead of having a list here, having it open a file. So let's actually do the same thing here and just opening the file so we can see how it's done for a whole for the rest of the problems. So new window, and we want to say input file is equal to open, and we called that file data.txt, and we want to read it. And then what we want to do now is go through that set of steps. So let's just actually put some comments here just to make things clearer for anybody who's reading your program. And we will say here, opening file to read in data. Okay. So we open that up. And then the next step is read. Actually, let me show you the command first, and I'll put a description so it makes a little more sense. Data string is equal to input file dot read. So let's describe what this step does, and we can say read in all the data from the file as a string. Okay. What's the next thing we do? We will give the following: data words is equal to data string dot split. Okay. And what does that do? Take the entire string and split it into words. Okay, so it's using anything where there's a space as a delimiter, it will actually use that. You can imagine that if you're working with a CSV file, you can specify what the delimiter being a comma and do the same thing. So it's the same type of a thing, except this time we're just using it as a space delimited. So we now have data words, we now want to create this, convert this into a set of numbers. So let's give the we have to create a for loop. Or first of all, let's create the empty list. It says number list equals. Right. So let's actually start a comment here. We want to say we want to excuse me. We want to convert the strings to floating point numbers. How do we do that? We do it for I, and where does it come from? It comes from data words. And what do we want to do? We want to create this list and keep tacking onto it each converted word. That's going to keep doing that. And then now what we want to do is just, whatever math you want to do. So in this case, let's actually calculate the sum. So let's say calculate the sum, which we already kind of know how to do. So let's just do that. Let's say s equals 0.0 for I and number list. S equals s plus I. And print s. Or you can be fancy and say print the sum of the numbers is s. Okay, we put it all together. Hopefully we didn't make any typos or any mistakes. And what you can now do is just run that module. We have to save it. And I'm going to call it read file sum data.py. Save that. And we made a mistake. So, and I'll let people kind of look at that and see where the problem occurs. I immediately saw it. Let's actually read the error a little more closely. And it says here, number list equals numbers list plus float data. Numbers list not defined. So if we look at this very closely, we can actually see that I made a typographical error, because this is number list and this is numbers list. So sometimes what you want to do is look at the error a little more closely, and if it says it's not defined, that's the problem right there. So we have to basically go back and fix that issue. Right. And one thing you'll find sometimes is if you make a big program and you get a lot of other errors, it's usually you want to start at the very top of that and try to figure out what's going on. So let's actually run this now. Run module, you gotta save it. And now another error. So argument must be string or a number. And we look at that and then we say, what did I do wrong? Well, what is data words? Well, it turns out, because I haven't taken any medicine, I typed this in to there, which is not what we really wanted to do. If we look back at how we did this, okay, when we did this interactively, and that's why it's a good thing to do things interactively, because you can prove to yourself that something is working rather than going in and jumping and writing this out. It's hard to sort of see what's going on. So we can see that what we really wanted to do is do a float I. Okay. So again, let's actually make that change here. And that's okay if you did that. That's a common mistake that most people made. particularly if you're still trying to learn what the for loop means. This is a list, and this would be the individual elements of a list. Right? So we want to actually access the individual elements of the list. So let's actually run that now. And hopefully there aren't any more mistakes. And yep, we did fine. So this actually allowed it to run and make the, calculate the values. And as you can see, you have, we can just change the file name and running it. We won't go into it now, but there are actually ways of having you specify the file name when you first run it. But for now, let's just assume that in order for us to make the change, we either change the file name or we can edit the data file. So let's actually prove that. We can actually go into data.txt. There's the file. Let's add another 100 there, so we can easily see that if the program runs properly, we should have a value of 208. So this is the file right here. So let's save this one. And that's one thing that you need to remember, is that if you make a change to a file, it really doesn't become useful to the computer until you've saved it. And that's why when we actually run this program and we made a change, it always asks us to save it before we actually run it, because you don't want it to use the old version of the program. So let's actually run this, and we're predicting that the answer we should get here is 208, since we just added 100 there. So let's actually run this now. Run module. Yep. So we can see now that you can actually do that. You can read in a file. Okay. So just to recap, we read in the file. Because the file is essentially a bunch of strings, we had to break it up into, first of all, read in the entire string. We had to split that up into essentially words, and then we had to convert those words to numbers, and we did that here. Now, question is, what if you had a letter here? So let's say the, for instance. Well, that can be problematic. There are ways of actually fixing that, but you typically, your program will basically break. Your program isn't very robust, so to speak. But let's actually see what happens in this situation. So just so you see what kind of error you get. So let's save this one. And then let's run it. Okay. So basically, it looked at it saw the part here and says, oh, I don't know what to do with that. So in this program, it's a very simple one, but you really have to make sure that all what you have in there is numbers and signs, such as the period, possibly a comma. Comma's not usually a good one, and plus minus, for instance. So and that's why there's a lot of things that really that's why it's so difficult sometimes to work with programs and make sure that they're bulletproof, because little things like this, which the users can easily enter into a file, can cause a program to basically not work properly. So let me just take a few minutes to look at the Python Lab B, and I think you should have enough information to actually do all of it. We've actually created the files. We've showed you how to read it in and write out the information, and you should be able to finish that fairly readily. So I think that's a lot of it. Now what I want to do is I actually want to poke at some concepts that we'll need for Python Lab C, and I just want to start with a couple of them. And one of them is a new data type that we haven't talked about but will become very valuable, and that is called a dictionary. All right. So the way to think about a dictionary is just it's a way to access a value through some other parameter, a tag, for instance. So let's look at the following. This is something that, and you can see why they call it a dictionary. So let's say create a dictionary, Spanish to English. And a dictionary is specified by having a brace and then the values associated, or the tag. Okay. So we can say uno, 1, dos, 2, tres, 3. And that's about the extent of my Spanish. So now you're going to ask, well, what does that, how does that actually work? It's just a very simple example. You can say Spanish to English, and we can actually insert the tag, and we should get the value back. So in this case, right? So we can say Spanish to English. And if you wanted to go the other way, then you'd have to basically create the English to Spanish case. So you would then have to say 1, dos. Sorry, other way. And 3. And while we're at it, let's actually create one from word to number, just to show that you can actually specify multiple data types. So in this case, I'm just going to have an integer there, but that could easily be a list with dictionaries in it. So the combinations can be very, very elaborate, but we start with this simple case so that you can sort of grasp what this is doing. So let's go 2, 3, and what you'll see is that you can actually start sort of converting based on these different dictionaries. You can start converting things to come up with the correct values. So for instance, I can say word to number, and then I can say Spanish to English, right? So we should get value 1. So by having all these different dictionaries, you can create what are known as lookup tables that allow you to convert from one form to another. So this is something that's very helpful. If we actually just printed out the dictionaries, so in this case we print out word to number. Okay. One thing you'll note is that dictionaries really have no order. It's entirely possible that this could have come out as 1, 3, and 2, And that's something to keep in mind when you're working with dictionaries, is that the order in which it is in the dictionary is not necessarily in a sequential order, because it uses the tags or the keys. That's the more proper term, to access the values. You have to. It really doesn't matter what order it's in. Just a couple of concepts also. If I said print word to number, keys are the things that you use to access the values. So, oops, print word to number dot keys. All right, print word to number dot keys. All right. Actually, let's look at the list of the dictionary keys. So we'll see that these are the keys that are present in the dictionary. We can do the same thing with the Spanish to English. The same. So as you can see, those are the keys. You have also another property of dictionaries called the values. So we can say print word to number dot values. And you can see that that's the values. Let's do the same thing for the Spanish to English. Values. So just a way of actually interrogating parts of a dictionary. So that's a very critical concept that we'll be using for one of the exercises in the lab C. So just want to make sure we have that concept of a dictionary, because one of the things that we'll be doing is we'll be creating a sort of a cipher. It's called ROT13, which is a very simple cipher, and we will use that to essentially encode a sentence into some unreadable but easily crackable code. So before we actually start that, the one thing that some of you may who have seen is that sometimes we do the import function. Actually, let's first of all let's start with some variables that we think should be in a programming language, or some operations that should be in a programming language. And one of them is the square root, for instance. Well, it actually turns out that SQR square root is not part of the language. So if I said print square root of 4, it hasn't been defined. If I want to print the variable pi, it hasn't been defined either. So what you will typically, in order to overcome these limitations, there are libraries that people create, and one of them is actually the math library. So we can say import math. And this is something that you'll be doing a lot at the beginning of any of Python programs, is importing different types of libraries. And sometimes what you would also see is that from math, import star. And that simply means is that you import all the possible definitions and functions that are within the program. But we can actually be a little more targeted by actually specifying specific functions. So in this case, we want to import square root. Now, if we actually want to use that square root function, it now exists. So as you can see, and if we want to say from math, import pi, we say print pi, you see that that now also exists. So this concept of importing and selectively accessing different variables and functions is an important one, because it is actually what extends Python to do much more powerful things than the common things that we've just done. So there are a lot of built-in things, built-in functions within Python, but there's many more that people have written and developed that you can access. The important thing with any modules that you do use is the documentation. So it's actually important that there's good documentation with it, because if there isn't, you really don't know what functions you can use and how to actually use them. So that's why I emphasize being able to look at some code, some documentation, and understand how to read them, because they are admittedly not the most accessible piece of writing. So we showed that for the math. We also have that for strings. So import strings, string, import string, yes. And I believe it's letters. A equals string letters, I think. Print A. Yes. So we have a set of letters here, and it's in alphabetical order. And what we want to do is use what's known as the ROT13, which simply means that you're going to rotate the order of the different letters by 13 spaces. So this is, let's call this the normal speed equals 8. And now what we want to do is we want to say rotated. Okay. And we basically want to rotate it by 13, which means that we want to start at the 13th element of the normal. And just to give you what this means, it's telling us to access all the way to the 13th element. So let's give you a easier example that is, let's see if we still have numbers here. So if I wanted to go from 0 to 2, I can say print number list 0 colon 2. Right. If I wanted to print from 2 on, I could say 2 colon. All right. And let's see, if I wanted to print the middle 2, number list 1 colon 2. Actually, does that make? Yes, yes. So just anyway, so if we look at what rotate looks like, it's that first half of the alphabet. We start all the way from N, went all the way to the end here. So what we want to do now is we want to actually tack the rest of that information. So we can say rotate equals rotate plus normal normal alphabet, starting from 0 to 13. Print rotate, and then print normal. Okay. So we now have a 2 strings, and what we basically want to do is to create a dictionary between each of those elements. So there's actually a special function called zip, which will take 2 lists and essentially zipper them together. So in this case, what we want to do is to create a dictionary that takes the normal letters and spits out the rotated letters. So let's actually do that. We will say something like, first of all, let's actually show what the zip functions looks like. So we want to take the sequence of normal and rotate. See what that looks like. As you can see, what it's doing is it's making an association with the different A to N, B to O, C to P, etc. So in this case, what we want to do is we want to now create that into a dictionary, and there is yet another special function that will take this kind of information, this kind of relationship, and create it into a dictionary. So let's actually call that encode is equal to, the function is called DICT, and then we're going to say zip normal rotate. Okay. If you look at that, we have this little relationship, this dictionary that allows us now to do the following. So if I say print encode and I give it the letter A, for instance, we get the letter N. If I say encode the letter R, for instance, with letter E. So what this means now is that we can actually have a message. And let's leave out spaces now, because spaces sort of give away information about the message. And we're just going to say right. And we have to somehow convert that into a encoded message. Well, let's just play around with this and say for letter in message. Before you actually do anything of significance, let's just make sure that we can print out each letter. Sure enough, that's what we're doing here. And now that we can do that, let's convince ourselves that we can convert that into a secret or an encoded message. And you would do that by simply saying print encode letter. Okay. So as we can see, if we actually look at this a little more carefully, we see that M corresponds to Z. Does that make sense? Yes, it does. Y corresponds to L, little l. Does that make sense? Little y. Nope, little y. Yep, big L. So it looks like it's working, but what we want to do is we want to now attach, instead of printing out line by line, or letter by letter, we want to convert that into an entire word. So, or at least an encoded word. So we can say secret message equals, and we start with just a null set of characters, and then we can say for I in for yeah, that's fine. I consistent letter in message, and we can say secret message is equal to secret message plus encode, and we want to say letter. Print secret message, and that's the secret message, and we can see that it's basically the same as what we saw here. So what we now will want to do is we'll want to somehow convert that secret message, send that out to somebody in order for them to sort of read this. They have to basically decode it. And how would we do that? Well, let's see, we have normal and rotate. So we have, if we look at encode, that's the relationship. What we need to do is do a decode, and the decode is fairly straightforward. You simply would say something like decode, creating a dictionary, and we zipped. In this case, we want to zip the rotate and normal. So when I say rotate and normal, I'm referring to normal alphabet and rotate alphabet. So let's look at that. Print decode. And I think we were successful in making that decode. So we can now say, let's be a little bold and just say print secret message. We won't say for letter and secret message. And we want to now say print decode and letter. And sure enough, we went through and got the original message back. So this is a ROT13, this is what's known as a ROT13 cipher. It's been around ever since the internet was around. It was meant more for not so much to be a very secure way of sending information, but more to keep information from being too easily seen, mainly for not so much censorship, but keep kids from reading expletives, etc., on the internet at the time. So this is ROT13, and it illustrates the use of dictionaries, which is a very powerful data structure. Without dictionaries, you would have to essentially go through and create a whole bunch of if-then statements to basically say, if I have an A, I want to convert it into an N, etc. So this actually makes it very easy to do that. It's very straightforward for specifying that. Let's see, I'm trying to think what else. So this is actually part one of the examples in Python Lab C. I want to hold off dealing with the last exercise in Lab C until I'm in I can answer questions. But what I do want to go over is some of the contents in Python Lab D, because it actually does relate to some of the things that we've recently done. So, so let's review by one of the things that we wanted to do. So it's one of the actions that we did. So let's look at the secret message. And we know that there's a len function in that. Okay. So what this is telling us is there's 15 letters or 15 elements in this string. So what we want to do is we sort of create our own len function, and we'll call that function count or my count. So let's actually do this the way we just showed it in Python Lab B. And say 0 for I in secret message. And we want to say C equals C plus 1. Print C. Okay. So that works right there. And what we want to do is we want to, the problem with doing this is that doing it this way is the fact that you always have to know what variable to put in here. So what we're going to do is create a function of this action. So we can create the following function. We can say define, and this is where I kept emphasizing as early as the Excel labs that you needed to know several properties of a function. The first is the name of the function. We'll call this one my count. And then the arguments of a function. And in this case, we don't really need to, we're just going to specify what's known as a dummy argument. And hopefully this will become a little easier to understand. But it's basically saying, I'm going to give this function some variable x, and I will operate on that variable x. So let's define some variables similar to what we have here. I say count equals 0. And then I will say for I in x. Sorry, let's try that again. Zero for I in x. Count equals count plus 1. Okay. And return count. Okay. What have we just done? We've defined a function called count, which does essentially what we did up here. Okay. One thing that you need to understand is that any variables that we define here is only available within this function. This variable x is something that we feed into the function. So let's look at what we can do here. I can now say print my count and then give it string. We can say print my count message, which should also return 15. And we can say print my count letters. Oops, there's no letters. Print my count letter. That wasn't letter. Oh, we have here. I'm forgetting what it was, but and let's make our own list. Please. Actually, let's assign this to a variable. Sentence. Print my count. As you can see, it did that. So hopefully you can see that writing things as functions is a lot more powerful because you can actually operate on different variables that get put in here. So let's for about 5 more minutes. Let's actually finish up by defining our own sum function. That's equals 0.0. And then for I and x, s equals s plus I. And this is where we usually print stuff out, but in this case, this is we want to return s. Okay. So if we now created a set of numbers, let's see if we have numbers here somewhere. Nope. Just create our own. Call it a equals 1, 2, 3, 4, 5. To print my sum of a. There you go. So instead of us having to either modify a file, an input file, or modify the program itself, we can write a function, and no matter where that data comes from, you can actually use the function to essentially do these calculations without having to rewrite the program that we created. So we'll stop there, but the concept of functions is one that I recommend that people get a handle on, because it is one of the more important concepts, not just in Python, but any other programming language that you happen to encounter in the future. Being able to write things in functions will make your life a lot easier. So I think that's all I have, and we'll catch you guys up on Tuesday. And if there's any questions with regard to the project, I still owe everybody a screencast, a Blender screencast. Hopefully I'll have the energy to do that tomorrow. So, okay, have a good night.